type of medical. Okay, so it says when conducting a statistical study, it is not always possible to get information about every person or situation to which the study applies. Whenever a sample is being taken, it's vital to be fair. In other words, the sample reflects the overall population. So if I said, okay, well, I'm going to take a survey of kids for ESM Day on what they want to do. Okay, first of all, if I said I'm going to survey everybody in this building, that's something that's called a population standard deviation. Okay, that means I'm talking about, I'm going to ask everybody's opinion, and everybody's going to get a vote on what they want to do. Okay, that's not always possible for someone to read through 2,000 kids' responses and look at everybody. So instead of doing that, they're like, okay, well, we'll just pick 2 kids out of this class, 2 kids out of this class, and 2 kids out of the class down the hall. Okay, and 2 kids out of every class. That is a fair sample, because I said I'm going to take 2 kids out of every class, and I'm going to get their opinions. Now, if I said, well, I'm only going to take the kids in the math department or the kids down at phys ed, you're not going to get a fair sample because you're not going to hit every single different type of kid in the building. All right? So that's called a bias sample. For example, if I said, there's a lot of things that we can refer to, but I want to figure out what the best toothpaste is in the country. Okay? And they always say the #1 recommended toothpaste by dentists is Colgate. We surveyed all these dentists, okay? But maybe all the dentists surveyed got free Colgate toothpaste to hand out to their clients. Don't you, when you go to the dentist, don't you get a little box of Colgate toothpaste? So of course those dentists are going to say, yeah, we like Colgate. They give us free stuff, right? Is it the best toothpaste? Maybe, maybe not. Who knows? Okay. So statistics, so that would be called a biased sample. Another example is if we wanted to, like say Conjo, who owns Destiny, say he wants to add a new store to the mall, okay? And he says, well, like some of these stores in the mall have gone out of business. One of them was like BCBG, Revolutions. BCBG was a high-end kind of like young person store. And they were really expensive. It's like a designer like, Tommy Hilfiger, but like even higher than that, So I knew that store wasn't going to make it because that store is geared towards your age, and the prices there are way too high, for kids your age. Like me as a mom, I'm not going to go in there and spend that kind of money on my child, And it's not like we have a lot of wealthy teenagers walking around this area. Now, do we have wealthy people in this area? Yes. Do we have wealthy people coming down from Canada? Yes. From New York City? Yes. And they do buy some of that stuff. But more of those people buy their designer stuff in like Coach, Marc Jacobs, some of the older stores, BCBG is a little too young for this area, I think. It's not like if they were in New York City, yes, they do great. So if I were to survey what I'm going to put in that new spot, okay, if he says, okay, well, I'm going to put some survey people outside of Dick's Sporting Goods, and I'm going to survey them when they come out. I'm going to give them the survey and give them a coupon if they do the survey, right? Is that a fair sample of people? No, because those people are probably sports-minded, and they probably want another sports or sneaker store in the mall. We have way too many sneaker stores in the mall, I think, but my kids don't, right? Right? That's one of the things you guys like is to go buy sneakers, right? Most teenagers. But if instead of putting the survey person outside of Dick's, maybe they should go to like stand outside of Macy's or stand outside of Five Below, because everybody goes to those stores, not just a specific type of person, right? Or maybe stand outside of Wegmans, right, and do a little survey outside of Wegmans, because everybody has to eat, right? Everybody has to go to the grocery store, right? So they'll get a more fair sample from standing outside of those stores, okay?
They could give them a coupon for Wegmans.
Well, no, usually like in the mall, they'll give you like a free ticket to like ride the carousel or something like that. They don't usually give you, or they'll give you just a specific, maybe a free pretzel or something like that.
Oh, I can go for free things.
All right, so this is what this example is talking about. It says, determine which television programs are the most popular in a large city. A poll is conducted by selecting a sample of people at random and interviewing them. Outside which of the following locations would the interviewer be most likely to find a fair sample? Explain your choice and why the others are inappropriate. So what would be the best choice here? Grocery store. And so we have to say why. So I'm going to kind of box it in. And you guys are not used to doing this by saying why is my answer right and why are the other ones wrong? Basically is what they're asking. So I would say a grocery store because you get a wide range of ages and incomes. Are you with me, Colin? No, you're not. Put that down. Put your screen down. Okay. And why are these others wrong? Well, the others are wrong because, like, these people would really want, they're sports-minded. These people are music-minded, right? Now, a comedy club, what's inappropriate about a comedy club is that you don't get all the ages. Can you be in a comedy club at your age? No. You got to be 21. And the age range for a comedy club is usually like 21 into the, maybe 50s or 60s. You don't see a lot of old people in comedy clubs because they can be a little not appropriate. You don't see, like usually it's kids, people in their 20s and 30s. So the age is an issue for the comedy club. Now, this stuff you will know. Mean, median, mode. You've done it since middle school. There's just a little twist on it. The mean is the average. To find the average, you add up all your scores, divide by how many you have, and that's the average. You guys have been doing that for years. The median means the middle value. You take off a high, a low, a high, a low. Remember that? And then you find the middle. The mode is the one that happens the most. Now for mode, if they ask you, like, when will you use mode, is if you talk about something that's not number-based. If I were to survey people about their favorite sports team, or if I were to survey people about their favorite color, or their favorite music person, or their favorite internet star, that's all things that are not number-based. And those things would be, you talk about the mode. Most people like the New York Yankees. Most people like the Boston Red Sox, whatever. Okay. All right, so then they'll say, when do you pick mean and when do you pick median as the best representation for the data? That's what they'll ask you. Well, you have to understand what this word outlier means, okay? It says you use the mean when there is no outlier, without an outlier. If there is an outlier, you use the median. I'm going to explain that to you, okay? So I'll give you a couple different examples of outliers. So if I took all the cars on my street and I went to every house and I say, okay, that's a $10,000 car, this one's $4,000, this one might be 10, 20, 30, the max probably about 30,000. But I keep going up and tallying, and I took all those cars, added them together, divided by the number of cars I had, probably about the average in my middle class development is about $20,000, right? But if a Lamborghini drives up the street and moves in next door, and that's like a $200,000 car, I think. I don't know how much they are. They're a lot. If I take that $200,000 and I add it in, my average now looks like the average car in my development is about $80,000. Is that true? No, there's no $80,000 car in my development except for that Lamborghini. But in our development, we have a guy that owns a really old classic car that's called, I forgot the name of it, my son knows it, but he says that car is worth like over $200,000. But it's like an old car that has like this nice motor, I don't even understand it, but whatever. So that's the nice car. And that actually has got that guy's pretty wealthy. He has like a motorcycle, an old car, he's got several cars. Okay, so that threw off my average. Now, let's do the same thing for homes. If you go buy your first home, like I did, I bought my first house when I was about 24, and I couldn't afford much because I just got out of college. I had a lot of student loans. I picked this really dumpy, it was like we were looking at really dumpy houses. So I picked this house that was the worst house on the street. It was falling apart. People were dumping their garbage in the back. Do you think the people around them really liked that house? No. The person next door said to me after we moved in, they asked us what we were going to do. The first thing, it was avocado green, and we painted it gray. I'm like, we got to get rid of that green. That was like from 1970s. So we painted it gray. It looked nice. But then we, got the garbage out. We we ripped out the stairs in the front that were falling down. Like, so we did some nice things on the outside, and then we really, my husband blames me because I like went crazy and said, no, we need, like I wanted everything to look nice. So we remodeled almost the whole house. So after we remodeled it, what do you think the value of the house, what happened to the value of the house?
It increased.
Kind of like on that show Flip or Flop. This is before, when they go and remodel these houses and they sell them. We stayed in there. We put way too much money. We really didn't make a lot on that. But it raised the value of the house. Before, when it was only worth $40,000, okay, what did it do to all the other houses in the neighborhood, to the value of their houses? It decreased it because that house was only worth $40,000. So when the realtors come and they do these, they add up all the prices in your neighborhood, it showed that, that $40,000, it brought down the value of all the houses in the neighborhood. It also brought down their taxes, so that kind of was a good thing. But then after I fixed up my house, it kind of raised everybody's, and the people next door never moved. They're like, okay, we'll stay, and we started fixing our house too. And so it was nice that everybody kind of, they were like, thank God you guys moved in and made it look nicer. Yes?
How long did you stay there?
Only 5 years, then I had to move because I had 2 kids right in a row, and it was a tiny house.
True.
But my mortgage was really cheap. I was really a good, and if I really liked remodeling and things like that. It was nice. It was a nice little development in Liverpool. But then we actually went to an apartment for a year because we were trying to build a house, but we could never build. It was too expensive. So
How was the apartment?
the apartment was okay. The apartment was almost bigger than my house. Yeah. So.
All right. So, what they like to ask a lot is they ask, what is the best measure of central tendency? So again, these 3 things are your measures of central tendency. So the best one, if you do not have an outlier, is always going to be your mean. But if you have that outlier in there, it makes your mean inaccurate. So in that case, your median is your best measure of center if you have an outlier. So when they ask those questions, all you really need to ask yourself is, does the data contain an outlier or not? And then that determines which one it's going to be. So those are our measures of central tendency. We also have measures of spread and variation. Now variation, they also use that to determine diversity. Is there diversity within the numbers? That kind of stuff. So we'll see some examples with that. But 2 data sets can have the same exact mean, but they can look radically different depending on how varied the numbers are. So the numbers can all be really, really, really close together and give you a mean. Or you can have numbers really, really far spread apart, but they will still give you that same exact mean. So the spread of the distribution refers to the variability. How much does it changes? If observations cover a wide range, the spread is going to be larger. If they are clustered around a single value, then your spread is said to be smaller because they're all closer together. So some values we look at when we're trying to determine our spread and our variation would be your range, which is just your high value minus your low value, so that tells you how far apart your numbers are. We look to see if there's any outliers in there, because again, that changes your spread because it makes it larger usually. And then we also look at your standard deviation. So that one's a brand new term, our standard deviation. That shows us how far a point is from the mean. So you find your mean, and let's say your standard deviation is 5. That means you're 5 points away from that mean when you have a standard deviation of 5. This part's important here. The larger the standard deviation, the greater the variation within your data set. Because if the standard deviation is large, that means your numbers are really, really far apart. So there's going to be a lot of variety in your numbers, a lot of diversity also, as they say. If you have a small standard deviation, all your numbers are really, really close together, so then you're not going to have a lot of variation in there. So here are some picture representations to kind of show our standard deviation. They like to use this little curve here a lot. So our mean is right here in the middle. This has a smaller standard deviation because the curve is all tight together. So that means all those numbers are really, really close to that mean. So it has a smaller standard deviation. It also has less variability, as it says right up here. Less variable, because the numbers are all so close. This one over here has more because see how it's a smaller curve? It doesn't go up as high and the numbers are spread out. It's a little bit wider. So that means it has a larger standard deviation. Because those numbers are going to be spread out more. Now when it comes to our standard deviation, we have two kinds of standard deviations that we deal with. First one is your population standard deviation, which is that little symbol right there. That's a Greek letter. It looks like an O with a little bit of a line attached to it. We call it sigma. Yeah. So you use your population standard deviation if you are actually getting your data from the entire population. So with her ESM day example that Mrs. Lorenzo was talking about, if you actually surveyed every single person in the building, that means you're hearing from the whole population, you would use your population standard deviation. The majority of the time, however, we use our sample standard deviation because it's really difficult to get the entire population. So if you don't have everybody, you're going to be looking at the sample standard deviation because that means you just have a sample of your population. So we're going to be doing a lot of statistics in our graphing calculator. This is a list of all the various buttons that we're going to be using today. So I find it's actually easier the first time to go through it instead of reading the list, actually do the example. So later on when you're doing your homework, this might be helpful for you. So let's take a look at our next page. So we have a survey was taken amongst 12 people on the number of passwords they currently have to remember. And these were the numbers that they gave us for their number of passwords that they have to remember. They want us to calculate the mean, median, mode, range, and standard deviation for this data set by using your graphing calculator. Round any non-integer answers to the nearest tenth. Yes?
So we don't have to show much work on the paper. We just
Correct.
have to just, round on the paper and then say the answer.
So I want you to get out your calculator. So we are going to be using this button right here. It says Stat. We're going to be using that button a lot this unit. So we're going to enter information. So we're going to go to Stat, and we want to go to Edit. So select it so that you see these lists. So if you have numbers in your list already, which a lot of you, if you're using one of my calculators, you probably do, what you want to do is you want to arrow up so that the L1 is highlighted up on the top. Push the clear button and then the down arrow, and it will get rid of all those numbers for you. Never, ever hit delete. Always clear. You want to clear your list out, so you're always pushing that clear button. So once that is cleared out, start typing in your numbers. So we've got a 0, so I'm going to hit 0, and then enter, and then I've got 3 1s. So I type my 1 in there 3 times. I've got 2 2s, so 2, 2, and then 4 3s, 1, 2, 3, 4, a 4, and a 6, 4, and a 6. So each number has its own spot on the list, and you're all in there. If you highlight your last number right down here, it should say how many you're supposed to have. This has 12 in there. If I look at my problem, they told me that they surveyed 12 people, so that means I got all my numbers right. You got to make sure you have all of them typed in, otherwise your answers aren't going to come out right. So are we all at this point where all of our 12 numbers are typed in?
Yes.
Okay.
It took me a second because I messed
Okay, well, let's keep going. Now, as for our next step, everybody's screen is going to be looking different. There's two different ways it's going to look. So we're going to go back to stat. And this time we're going to go over to calc, because that means we're going to calculate values, which is exactly what we want to do. So stat over to calc. We've entered in one piece of information, so we want this first one var stats. And we're going to hit enter. Now, some of your calculators look like mine. If it does, you don't have anything else you need to do. You're just going to hit enter and you're going to get this list of stuff. Others of you, you're going to have a little list. It says, I believe, list. That needs to say L1, which 99% of the times it does. Then it says freak list. That should be blank. Don't have anything in there. And then just hit enter until you get down to calculate. So L1 blank, and then go down to calculate. And you should get that same list also. Yes, ma'am. Right here. This first one, X bar, that is your mean. So if we look up here, they told us to round to the nearest tenth. We'll put the little X bar next to mean, so remember that's the one it is. So rounded to the nearest tenth, what is our mean? 2.4. So now, we got a little arrow here. This tells us we have more information. So let's scroll down.
Wait, are they not supposed to be the same thing?
They should be exactly the same. You typed in the same numbers as me.
Did you put it at 0?
MED right here, this is your median. So our median is 2.5. The calculator doesn't tell you your mode. You just have to look at your data set. What number was there the most? 3. 3 was up there 4 times, so 3 was our mode. Range, that's another one they don't give you. You got to do your high minus your low. So what was our highest value?
6.
And then our lowest? So 6 minus 0 means we have a range of 6. The other thing, though, your calculator does tell you, here's my max, here's my min. So if your data is not in order, it will pick those two out for you, so you don't have to search around for them. And then our last one, standard deviation. We have to ask ourselves first, did we have the entire population or did we have a sample of people? Sample of people. So we want our sample standard deviation, which is the capital S with the X. So if we arrow back up, here's our sample standard deviation to the nearest tenth. That would be what? .6. So then they ask us which measure of center would be best to describe this data set and why. So we have to ask ourselves, was there an outlier in our data set? Was there a number that was really, really far removed from the rest of them? Aaron? That's not really far away though. That's only 2 away from the 4. An outlier would be like if my next number was 15. 15 would be an outlier because it's really far away. But we didn't have that. All those numbers were really close together. So this one does not have an outlier. So since there's no outlier, our best measure of center is your mean. And the reason being is because there is no outlier. All right, so our second question there, it says, which of the following data sets have a standard deviation closest to 0? Do this without your calculator and explain how you arrived at your answer. So again, if we have a standard deviation closest to 0, that means your numbers are really close together. If we have a standard deviation close to 0, there's not a lot of variation in our numbers. They're pretty much going to be almost exactly the same. So if we look at our 4 choices there, which set of numbers is the closest together? Choice 3. So then our explain how you arrived at your answer would be because they are the closest together. All right, 3, a marketing company is trying to determine how much diversity there is in the age of people who drink their different soft drinks. So they take a sample of people and ask them which soda they prefer. For the 2 sodas, the age of those people who preferred them is given below. So we got our soda A and we got our soda B. So first, they want us to explain why standard deviation is a better measure of the diversity in the age than the mean. Does anybody think they know? Johnny? No. No, that's not why standard deviation would be the one that we want to use. The mean tells us the what? Your average. Standard deviation is how far away from the average that you are. So that's why we want to use it. The standard deviation tells us how far apart the numbers are. So then for the next part, I want you guys to practice this in your calculator. They want to know which one has the greater diversity in the people who've picked them. So that means let's find our standard deviation. So this will be good practice with your calculator again. So under your L1, type in first your numbers for your soda A and get your standard deviation. And then do the same thing for your soda B.
So let's look at the difference in the standard deviation. The standard deviation is much higher for soda A than soda B, right? This is greater than. Which soda appears to have a greater diversity in age of people who prefer it? How did you decide on this? I plugged it in my calculator. I found the standard deviation. Okay? So what if, look at, so this one says 9.09. Why? Because we've got a 40-year-old and we have a 16-year-old. Here, the difference, we have a 30, and I think the youngest is 18 here, okay? So the spread is much, this is like your diet soda group, right? These are the older diet soda people. This is like your Mountain Dew group.
Yeah.
That's stuff that I don't know how people drink.
You don't like Mountain Dew?
That is gross.
It's so refreshing.
It looks,
like a cold Mountain Dew is like so good.
it looks like something aliens would drink. Like looks like it's fluorescent, and you're gonna, anyway.
Oh, I never had the chance to drink it anymore, so you don't have to worry about it.
All right, let's look at the next page. All right, so now go clear out both your lists. Clear out both your lists. And I'm going to come around and check everybody. I want everyone to plug in that first list. It's long. Now, I'm going to show you how I do it a little bit easier. Ready? Is I group these together. Like here, I grouped together 24. There's 3 24s. There's 3 25s. There's only 2 27s, so I underline those. There's 3 28s. There's 3 31s. There's 3 35s. And that's it. So when you plug it in, it's easier to plug them in. Also, we could do a couple of these before we even get into the calculator. So what's the range? Let's do this before. The high is 70. The low is 19. This is talking about minutes people are taking on a test. So 70 minus 19 is going to give me 51 minutes is the range. This standard deviation, this is a sample. So when you do this in your calculator, you're going to do the S of X again. Mean, you're going to go look for your X bar. Median is too hard to figure out. Mode, we're going to do mode together before you guys do this. Which one happens the most? See those ones that I blocked in? 24, 25, 28, 31, 35. Those all happen 3 times. You can have multiple modes. Okay? So now the rest you are going to do on your own. So you're going to plug these in your calculator, and you're going to give me your mean, median, and standard deviation. I'll come around and see how you're doing. Was it? Did I stop it? I didn't stop it, did I? Is this one here? So it looks like the people got that the median was 28.5. Is that right? How about the mean? What was the mean? The first one? 30.5. And how about the standard deviation? 9.72. Is that a high or low standard deviation?
I got 17. 17.
Oh, sorry, I didn't hear. 9.17, okay. 9.17. Now, is this a high or low standard deviation? 9 is kind of a large number, right? We're 9 from the middle. That's what standard deviation means.
What does that say?
Now, what do we have an outlier here? That's a large. It says large. It's a large number.
Sorry.
Do we have a standard an outlier? Yes. It says right here the outlier is 70, right? So now what we're going to do is we're going to go back into that sample, and it says take out the 70. So go into your list, find the number 70, hit delete, and then do all this again. Find your X bar, find your median, find your mode, find your range, find your standard deviation. Go ahead, do it. It should take you only a second to do. Go into your list, delete the number 70. You never plugged your list in. Right? You still haven't plugged your list in.
So once we delete the 70, we do the...
Oh, you do it all over again, yes.